Okay, hi. So good day, everyone. Today what we're looking at is writing augmented matrices for systems of equations. So this slide will cover some vocabulary that's going to be very important. So just watch as we go along through everything. And as always, if you have a question, please don't hesitate to ask. If something is not clear for you, say something. Remember, you can go back and rewind or review this at a later time when you have more time. Okay, so this is just some of the key vocabulary that goes with this lesson. A matrix is just a rectangular arrangement of numbers. So as I fill in the words here, I want you to write those down because this is going to be some of your points for your class kick assignment. Okay, so the first one is a matrix is a rectangular arrangement of numbers. The dimensions of a matrix with m rows and n columns are read as m by n. So here we go. Put the word dimensions there. Excuse me, it's messing up. Or it could be just me messing up. Okay, so the dimensions of a matrix is m by n, or we go how many rows by how many columns. And so rows are left to right, that's your horizontal, and your columns is going to be vertical, straight up and down. So if we look at, so the dimensions of matrix A are 2 by 3. The numbers in the matrix are its elements. Okay, so that's another important word right there for you. It was kind of hidden, but this matrix here has 6 elements because it has 2 rows going left to right, and it has 3 columns, so there's a total of 6 elements in matrix A. So the element in the first row in the third column is 5. The element in the first row in the first column is 4. So that will be used, those words, matrix, dimensions, elements, will be used throughout this lesson. Okay, so I just want to point those out because those are going to be important. Give me just a second, I'm gonna highlight them too, just to make sure we're on the same page, same chapter, same story. There you go. All right, so now what else is important? A matrix derived from a system of linear equations, each written in standard form with a constant term on the right, is the augmented matrix of the system. So what happens is you may see this done in different ways, but what is going to be most important is that the equation is in standard form. Okay, for example, the system below can be represented by the given augmented matrix. So let's just say that we have 5x plus 3y minus 2z equals 1. So what the book chose to do is put dots between the variables, our coefficients, and our constant, which is to the right. So notice that there is no variable, there's no x, there's no y, and there's no z there. Okay, so when you write your augmented matrix, you're only going to have coefficients, which are numbers. Okay, that's the number in front of each variable. Now, so I want you to see what has happened here. So the second row, we have x plus 2y plus 3z equals -1. Notice that in the place of x, there's a 1 because the coefficient for x is 1. Okay, don't make that a 0. That's a common mistake that students will make. But no number in front of a variable just mean that there's one of them. So we have 1, 2, 3. And if you look over here on our augmented matrix, we have 1, 2, 3. And that's equal to a -1. So on the opposite side of the equal sign here, we have a -1. Excuse me. So and then it goes on, 3x minus 4y plus z equals -10. So we have the 3 as the coefficient, -4, and then the 1 in the place of z because it's understood to be a 1 in front of the z value, and that equals 10. So notice our constants are to the right, 1, -1, and 10, and all of our coefficients, our numbers that are in front of our variables, is on the left hand side. So 2 things that are going to be very, very important for you, and I put it here so that you can write it in as vocabulary. So get your points. Number 1, before you write an augmented matrix, make sure each equation is written in standard form. Okay, that's very, very important. And when I say standard form, all I mean is that your variables, 5x, 3y, 2z, are on the left, and your constant, it always equals a number, okay? And I'll get into that when we get to some other examples. So make sure it is written in standard form. If, for example, we didn't have this x variable here, and if it just was 2y plus 3z equals -1, then we would have to put a 0 there as a placeholder. So that's what goes on the second rule here, or the second note that's important. Uh-oh, I pressed the wrong button. There we go. All right, so down here it says include zeros for the coefficients of any missing variables. This determines the order of the constants and coefficients in the augmented matrix. So like I said, we're going to get into that a little bit more, but I want to scroll to the top so that you can see that these are the most important things as it's related to vocabulary for this assignment. So the first thing is that it's a matrix. It's a rectangular arrangement of numbers. The dimensions are written, kind of look like multiplication, 2 by 3, 3 by 4, those things. Each number inside of the matrix is called an element. We have an augmented matrix when we have a system, because we have an equal sign, so you'll probably have either these dots here. Sometimes it's shown as a solid line, and that's okay, but just know if it says an augmented matrix and you see either dots right here or a line right here, then that's just representative of your equal sign. And then your equations must be in standard form. Doesn't matter the order, as far as like if your first equation is 3x plus y equals 4, and then your second equation is 2x plus 3y plus something z equals a number, that doesn't matter. But what does matter is that the order of x, y, z, just like in the alphabet, x, y, z, okay? So if you're missing something, you're going to have to put a 0 as a placeholder. And then you have to include a 0 as a placeholder. I got ahead of myself. So that is the vocabulary for the lesson for today. Let me or one of your coaches, Mr. Jackson or Mr. Williams know if you have any questions. We are all here to help you, okay? So let's have a great day.